n cosine theta minus 120, n c theta is n cosine theta plus 120, right? I put 3 winding, so this one is 0 here, the shift is here. See, for example, phase A, I started here, right? Where phase B should start? 120 after here. So let's call it, this is 90, I don't know, it's almost 20, almost something, right? So basically, phase B should have 0 winding here, right? I'm going to use the same slot. Don't think I'm going to put this. I have to, when I'm selecting this slot, I have to make sure I have the good numbers of them, you know? But for example, let's say, okay, phase A, I'm not going to put any winding for phase A here, right? Let's say this is the 90 plus 22 is going to be how much? If I have put, let's say, I have put it this way, would be better. No, 0, 30, 60, 90 would be perfect. No, I put it 2.5 is not good. If I had it like this, I said 0, 30, 60, 90, 120, 150, 180. Like this, right? So for phase A, I'm going to put 0 winding here, right? 0 winding here, right? The maximum numbers here, the maximum numbers here, right? So this is sinusoid, you know, we talked about it. For phase B, I'm saying, okay, the 0 should start at where? 120, is it? 1, 2, 3, 4. I'm going to, sorry, 1, 2, 3, 4. I'm going to put 0 winding here, right? 90 degree after this, I'm going to put the maximum number after it. 1, 2, 3, 4. I'm going to put in this slot, I'm going to put the maximum number. For phase C, 1, 2, 3, 4. I'm going to put 0 here. My point is, don't think I'm going to have 3 sets of slots for each phase. You come up with 1 set of slots in the machine, and you start to put this winding there. Now, I have a 3-phase winding. Each one sinusoidal, like this, right? I'm going to connect it to a 3-phase source. You know, all of you know what's a 3-phase source, right? I'm going to inject this current, IA, theta E, will be IM, cosine omega t see, this is very important because this is how the machine works, how the physics of the machine works. The rest, after we pass through the equation, those kind of things, you know, that equation is simple, you know, you put it there. But you should understand how the machine works, how the machine behaves. So IB IC theta and let's call this one, we call it, let's call it, let's give this name F of theta, right? So now we're going to have a 3F, right? FA, right? FB. So this current is going to go through this winding, right? FB and FC. Let's calculate each other. FA, FB, FC. How much is the FA? Is N IM cosine theta E, which theta E is omega, right? This is omega. Sorry, it's a theta. Cosine omega, right? This one already calculated here, right? Is going to be N IM over 2 cosine of omega t minus theta plus NIM over 2 cosine of omega t plus theta. Let's call this one FA plus and call this one FA negative. Right? Let's do the same thing for phase B and phase C. This is what we have. FB theta. So again, it's going to be NIM over 2 cosine. So let's hear. Alpha minus beta, right? Alpha minus beta. This is the alpha, right? Theta E minus 120 minus this, right? Oh, something like this here. I want to do the other way. I want to call this one alpha. I want to call this one alpha, this one beta. So it's going to be cosine of alpha. It's going to be this one, right? I'm going to write it once. Omega t minus 120 minus beta, right? No, something.
It shouldn't be.
No, some of them is wrong.
No, it shouldn't be omega t.
This is the theta, sorry. This is the theta. This is the theta and this is the theta. Now we'll go back here. This is the alpha, this is the beta. Right. So it's going to be alpha minus beta. So it's going to be theta E alpha minus beta. What is going to be? This one is going to cancel this, right? Minus minus is going to be positive. So it's going to be theta E minus theta, right? Theta E is omega t, right? Just write it down. It's going to be cosine of omega t minus theta. And how about the other one? It's going to be alpha plus beta. This is alpha, right? Theta E minus 120 plus this one, theta minus 120. So it's going to be theta E plus theta minus 240, right? Minus 240. Let's put it there. So let's call this one FB plus and this one FB negative. How about FC? Right. And you know, just here, let me say. Here you can say what? Instead of minus 240, you can say what? Plus 120, right? Plus 120, right? So it's going to be this one cosine of theta plus 120 is going to be NIM over 2 cosine of omega t minus theta plus NIM over 2 cosine of omega t plus theta plus 240. Right? Instead of plus 240, I can put what? Minus 120, right? Let's just replace this over minus 120. And let's call this one FC negative. Let's call this one FC positive. Look at it. FA. Write it down on this one. Now, let's look at here. What do you see about the FA plus, FB plus, FC plus? They're the same, right? Let's call it F plus. F plus, we call it F plus. Is FA plus plus FB plus plus FC plus. So all these three together, they're going to be like one magnet, right? Is rotating to the positive direction. It's going to be 3 over 2 NIM what cosine of omega t minus t, right? There is a magnet, for example, going in the positive direction, and it has this much of magnet, right? 3 over 2 NIM. What What do you say about the FA minus FB minus and FC minus?
Those are all B and C, they were us.
No?
R and B and C.
That is true. This is the definition of a balanced three-phase system, right? 0, 120 minus, doesn't matter. B is must be more C, right? 0, 120 minus 120. If in the three-phase system, if I had a balanced system, how much was the VA plus VB plus VC? Or IA plus IB plus IC, it's going to be 0, right? For any balanced three-phase system, all add together is going to be 0. So what's going to happen here? I'm going to have one F negative, right? It's going to be FA negative plus FB negative plus FC negative. See what I'm saying this one? Because this one and this one and this one here are all rotating in the opposite direction, right? These three, they are rotating this way. For example, let's say counterclockwise. These three, they are rotating counterclockwise. These three, they are rotating clockwise, right? But if we look at these three all together, they're going to cancel each other, right? So this one is going to be how much? 0. So what happened? I got rid of one of the magnets, right? Now I have only one magnet rotating, right? So I got what I want. I have a one rotating magnet. With what speed is rotating here? This is the speed of rotation, right? So this is the basic of the induction machine. And synchronous machine, they are pretty similar also. I created a moving magnet. So I put a three-phase on my stator, right? I put three-phase in my stator. If I have I put another three-phase on my rotor, right? The same way. This one also is going to create, if I put a three-phase like this one, similar structure. This one also is going to create another one magnet, right? Each phase again is going to be two magnets, right? But based on what we went through, this one is going to have one magnet, rotating magnet. This one is going to have one rotating magnet, and they're going to live together, right? And they live together, and the rotor is going to start to move. So now let's look at it a little bit more. You know what happens. So we know how the machine is going to work. How we are going to have a rotating magnet inside the machine, using a three-phase winding and three-phase source. So the next step is, let's get to the basic equation now of the machine. Instead of going through that picture over there, it's too complicated, too many windings, those things. We said, okay, we can make it central. This is, all the machines are like this. If you look at them, they are not like one slot. You can put one here for phase A, right? So you go like this. The best thing is to have something like this, see? We calculate that one, right? Based on the sign. We assume the n is like this, right? But in reality, it was not like that. It was like a staircase, right? So people listen to the numbers that they can do like this. Right? One slot. This one is going to cause harmonics, but it still is going to work well, right? This is a sine, is a square wave, right? How to have this one? Look at this. If I create my machine like this. I'm going to put my phase A, for example, here. I'm going to start from here. Phase A here, that's one slot, right? Phase D is going to be, or B or C. Let me put it here and here. This is one winding here, right? One winding here and one here, right? So if A is here, B is here, and C is here, so basically this is a C, I'll call it CC prime. This is the A prime. A prime, I mean every winding you can see is like this, right? I call this one A, I call this one A prime, right? A and A prime. One leg is here, one leg is here, right? So, and this one is going to be DB prime, right? These three together, they are going to generate a magnetic field like this. I'm going to call it FS. I'm going to call this one Fs, magnetic field, which is rotating with the speed of excitation. And this is the tape. This is the tape. This one is rotating like this. I made it just, they call it central winding. One slot. I don't think so you can find any machine like this, but for teaching, I just kind of be much easier to do only one slot. You know? So this is how we show the, we call it state. This is, I call it Fs. I call it Fs. S because this is a stator, right? This is the stator part, a stationary part, right? For this one also is going to create another magnetic field, right? We call this one F rotor, Fr. So you have the two magnets, like the one I put in the rail. I should have two magnets, right? One is moving, it's going to push the other one, right? A stator has one magnetic field, is rotating. Rotor has another magnetic field. This one, this magnet, a stator magnet, is going to push the rotor magnet to start to move, right? Now, let's get to the more equation. Any question here? Now, the same equation we had for the DC machine we have here. Theta electrical is equal to what? 5 over 2 what? Theta mechanical, right? Here again is a two-pole machine. The one I showed here is a two-pole machine, but you can design it to be, I don't know, as many as poles you want. You know, you can design that one. Theta is equal to V2, or you can say omega electrical is over to the same thing we had for DC machine, or you can say F electrical is Q over 2 F mechanical. The same equation we had for the DC. For every electrical machine, this equation is correct. You can use it. Now, this magnetic field is rotating with omega, right? If, see, here we have, let's say, 60 hertz frequency. Let's say we have a 60 hertz frequency here, right? This one is going to rotate with how much? It's going to rotate with, I don't know, 2 pi times 60. How much is it? 377. 377, right? So this one is rotating with 377. Think about it, this is the generator for it to be easier, you know. Generator, we rotate this one, right? This one is, we want 60 hertz, right? At home we do 60 hertz. So basically it means there is a magnetic field is rotating with 60 hertz, right? I am myself, I am the prime mover for this rotor, I'm going to rotate it with 50 hertz, right? So the speed of this rotor is going to be 50 hertz, mechanical speed. So winding inside this one, what kind of frequency do you have? See, this machine, we are rotating it with 50 hertz. We have 60 hertz here in the stator. What frequency do you have?
100.
Hmm?
100.
Why 10?
It's calculating the relevance of the weight.
Think about the two magnets I said, right? I said two people in the rate. You're moving the first one, for example, with 1 meter per second, right? The other one has to move with 1 meter per second too, right? So they have the same speed, the speed of magnets, right? Here, the speed of this magnet is how much? 60 hertz. This is not the speed of magnet. I am rotating this machine, right? And I'm creating some frequency here. How much? 50 hertz. So this magnet also has to, the magnet created by this rotor also has to rotate with 60 hertz, right? If it's going to be a steady state rotation, right? This magnet and this magnet, they should rotate at the same speed, right? So I'm rotating this one with 50 hertz, right? So the current in the winding also should have another 10 hertz, right? 10 hertz plus 50 hertz I'm rotating.